Hello, and welcome to this week's Camp Insights Program of the Week. Doing this a little bit early in the week so that my students can look at it before they take uh, my midterm programming exam. So this is coming out on a Tuesday instead of the usual, Thursday-ish timeline. Okay, what we're going to do today is a program that calculates the density of um, spherical particles to see if they will float or sink in a particular liquid. So, um, the what we're going to do is we're going to read in a vector of masses and then a vector of uh, uh, diameters, and then calculate the density. And then we're going to read in the density of the liquid we're supposed to be floating them in. Okay. Um, so we need to pound include the vector library. Um, and we probably need to pound include the IOmanip library so that we can make the output look nice. We are using namespace standard line. Okay. Don't need this gobbledygook in the int because we're not taking command line arguments. And we don't need to say hello world. Okay, so what are we going to do? Well, we need a vector of type double called masses and a vector of type double called diameters. Okay, we don't know how big these vectors are going to be yet. That's why we're using vectors. If we knew that we were doing exactly 5 or 10 particles, we would use an array and just set out exactly 5 or 10 spaces. But since we don't know how many we're reading in, we're going to use vectors. Okay, then we're going to start with a mass equals 0, 0 and a diameter equals 0, 0. And then we're going to use a sentinel value to end up, you can't have a negative mass or a negative diameter. So I'm going to say const int sentinel equals -1. Okay. Now by C++ convention, if we make a constant, we often capitalize the whole thing to just remind us that it's a constant. Okay. Now, what do we need to do? We need to read in these masses and diameters in an array. So while mass does not equal -1, or does not equal sentinel, okay, we're going to cn mass. Now actually, the best way to do this is to read in one mass first. So cout, enter the particle masses type -1 to end. End line. Okay. Then I cin my first mass, and it checks that mass does not equal sentinel. And if that's true, then masses dot pushback mass. And then we cin the next mass, which could be a sentinel value or it could be a legit mass. Okay. If it's the sentinel value, it gets caught as soon as we hit back to the while loop. If it's not a sentinel value, it gets pushed back onto masses, and then we read another mass. Okay. All well and good. Now, we're going to read in the particle diameters. But we know this time how many particle masses there were, and we're going to have the same number of particle diameters. We don't want to have more or fewer. So we're actually, instead of a while loop, going to use a for loop. Int, say count equals 0, count less than masses dot size, count plus plus. And here we're going to do it in the other direction. We're going to say cin diameter diameters dot pushback diameter. Okay. So we've got the particle masses. We've got, oh, I forgot to hit my prompt here. Enter the particle diameters end line. Okay. So, and what I actually can do, because we don't want them to get confused about which particle they're entering the diameter for, is for each one of these I can see out particle number count plus 1 colon. Okay. So now I've got my particles. Finally, I'm going to have a I need to know the density of the fluid. So double fluid density, cout, enter the density of the fluid, cin fluid density. Okay. So now we've got all the things we need to do our computation. What we're going to do now is run through we're going to cout particle number, and then set with, say, 10, density, and then set with 7, float. Okay. All right. Then we're going to, for I equals 0, I less than masses dot size, I plus plus, we're going to see out set with 5, I plus 1 for the particle number. See out set with 10, density of masses at I, diameters at I, and then we're going to see out, then we're going to if, okay, if, oh wait, I need to actually store the density. Okay. Okay. Oh, I can't have a function and a variable with the same name, can I? So we'll call this dense. Okay. Now, if dense is less than fluid density, actually, let's call it particle density. I'm using an IDE. I can copy and paste. I don't need to use short variable names. Okay. If particle density is less than fluid density, then we're going to see out set with 5, say, Y for yes. Okay. And then inline. Else, we're going to see out set with 5, no, inline. Okay, now do you see the error I made? If the particle density is exactly the same as the fluid density, it will still float. So that's got to be a less than or equal to fluid density. Okay. So the last thing we need to do is write this density function. So let's copy the function call here and run up to the top and paste it there. Now density is going to return a value of type double. Okay. And it's going to take a mass and a diameter and it's going to calculate some things. So the volume of a sphere, we're assuming these are spherical particles, is 4/3 pi r cubed. So equals 4.0 over 3.0. Make sure you use the 0.0s so you don't get integer division. 4 divided by 3 is just 1 in C++. 4.0 over 3.0 times pow of diam over 2 cubed. Okay. It doesn't know pow here. Oh, it doesn't. I forgot to give these types. Double mass, double diameter. That will clear that up. Now it doesn't know pow, and that's because I forgot to pound include which library? CMath. Yes, okay. Now I've got the volume. Density equals mass divided by volume. That's our basic formula. And then to send it back to the calling function, we return density. Okay. So this covers this serves as kind of a nice little review for the midterm exam. You're going to have a question about writing a function that takes a value, returns a value. Okay. You're going to have questions about outputs and inputs and input loops. So this reading in a value, then checking to see if there's a sentinel, then adding it, doing another read, going back, that basic loop format. Okay. You'll have questions about for loops. And you'll have at least one question that requires you to do an if else. Okay, so you'll need to know how to do conditionals. Okay, now let's just check to make sure that this program works. So my particle masses are 2.1, 3.4, 0.9, 1.7, 4.8. -1 to end. Enter the particle diameters. Now see, it's showing me particle number 1, so I can look up there and see that's 2.1. I think I want the particle diameter for that to be 0.75. The next one I want to be 1.55. The next one 0.52. The next one 1.01, and the last one, big heavy particle, so it's probably got a bigger diameter. We'll go with 2.41. Yeah, enter the density of the fluid. We'll go with 0.95. And none of those would float because all of them are too heavy for 0.95. Okay, So I've got to use smaller masses next time. Or bigger beads, one of the two. Okay, so let's try again, see if we can get some to float. 0.9, 1.1, 0.75, 1.25, 0.6, 7. Okay. Now particle diameters, we'll go with some slightly bigger particle diameters than we did last time. So 1.0, 1, 2.02, 2.55, 3.14, and make sure at least one of them floats, we'll do, or one of them doesn't float, 0.75. And the density of the fluid, 0.9. And there, okay, we've got some that are too heavy and they don't float, some that are light enough that they do float. Yay, the program works. Okay. All right. Once again, thank you for joining me for our program of the week. If you liked it, go ahead and hit like and subscribe on YouTube. I look forward to seeing you again next week. This is I look forward to seeing you again next week. Until then, good luck and happy programming.